So in today's lesson, students will be able to multiply and divide integers. So before I even go over how to multiply and divide integers, I'm going to make one thing very clear. Multiplying and dividing integers are so easy that students forget their adding and subtracting rules. So please keep that in the back of your mind when you're learning this lesson today, that when you multiply and divide, the rules are a lot easier to understand than when you add and subtract integers. So to multiply or divide the number without the sign. Right now, whenever you see a multiplication problem, so for example, -6 times 5, multiply it like there was no negative sign. So just do 6 times 5, and you get 30. And that's what this step right here is saying first. Then the second step is asking you a question. It's saying, do the two integers have the same sign? So over here, we'll write the word yes, which means that the answer is positive. Over here, we'll write no, which means the answer is negative. Going to my example of -6 times 5. -6 is a negative, and +5 is a positive. Because signs are different, because signs are not the same, it means my answer is negative. So my answer in this case would be -30. If signs were the same, it would have been a positive answer. So for example, over here, 7 times 2, notice how they're both positive. So the answer is 14. Now look at -7 times -2. In this case scenario, they're both the same sign. And if they're both the same sign, it means that the answer is positive. So -7 times -2 is also positive 14. You only get a negative answer if signs are different and you're multiplying or dividing. So let's do the next two together, and then after do these two examples, I'm going to have you pause and do some on your own and then check the video to see if your answer is correct. So in example 1 here, -2 times 5, just do 2 times 5, which is 10. Then ask yourself, are signs the same or different? If they're the same, your answer is positive. If they're different, your answer is negative. Because in example 1 here, signs are different, one's negative, one's positive, my answer is -10. Notice here I'm not asking about the players on the team anymore. Absolute value does not matter. It doesn't matter if there's more negatives on the team or more positives on the team. If signs are different, it's always negative. If signs are the same, it's always positive. Now let's go ahead and do this example. -7, negative, times -5, negative. First, let's do 7 times 5, which is 35. Then ask yourself again, are signs the same or different? In this case, they're both negative, so the signs are the same. If they're the same, my answer is positive, so my answer is positive 35. Okay, so for now, for 2 and 9, do it on your own. So hit pause, try it on your own first, then hit the unpause button, and then see if your answer is correct. These two I'm going to go a little bit faster, so you should pause right now. Okay, welcome back. So in this problem, it's 9 times -3. Because I don't see an operation, it always implies multiplication. 9 times -3, 27. Signs are different, so -27. In example 9, once again, I do 9 times 4, which is 36. Signs, once again, are different. One's positive, one's negative. So different means negative. My answer is -36. Here, once again, pause, try these two on your own, and then watch the video to see if your answer is correct. In 3, it's 7 times -8. 7 times 8 is 56. Signs are different. One's positive, one's negative. So the answer is -56. In example 10, once again, this implies multiplication because I do not see an operation. So I do 5 times 4, which is 20. One's negative, one's positive. So signs are different. So the answer is -20. Okay, example 4, we're multiplying again. What I want you to do is to pause, try the two on your own, and then unpause. So in this problem, it's -9 times -10. First, I do 9 times 10, which is 90. Then I ask myself, are signs the same or different? In this case, because they're both negative, they're the same. So my answer is positive 90. In example 11, I first do 3 times 8, which is 24. And then I ask myself, are signs the same or different? Because they're both negative, my answer is positive. Once again, if signs are the same, the answer is always positive when you're multiplying or dividing. Here, try the two on your own first, so hit the pause button, and then unpause it to see if your answer is correct. Most of you will probably get 5 correct. but example 12 might be a little bit more difficult. Example 5, once again, negative 8 times negative 8. I first do 8 times 8, 64. Then I check the signs. Because they're both negative, my answer is positive 64. With 12, because you have three numbers, there's something I always said in the past, and I'll say it again. Take it two numbers at a time. So right now, 12 says 2 times negative 3 times negative 7. I would do 2 times negative 3 first. Don't even worry about the negative 7. 2 times 3 is 6. Because one's positive and one's negative, it's actually negative 6. Now I'll bring down the negative 7. And now I'll solve these two problems. So now I'm going to do 6 times 7, which is 42. And because one's a negative and the other one's a negative, that means that both signs are the same. My answer actually ends up being positive. So my answer is positive 42. 2 times negative 3 times negative 7 is positive 42. Once again, pause, try these two on your own, and then unpause to see if your answer is correct. Most of you should get 6 correct. 13 might be a little bit more challenging. So with 6, it says negative 1 times 7. So I do 1 times 7, which is 7. From there, one's negative, one's positive. Signs are different, so my answer is negative 7. For 13, there's three numbers, so take it two numbers at a time. Look at the first two, and just do negative 1 times 2. Negative 1 times 2. 1 times 2 is 2. Because one's negative and one's positive, it's negative 2. I bring down the negative 3, and then I multiply again. 2 times 3 is 6. But in this case, now they're both the same sign. They're both negative. So my answer ends up being positive 6. And the last two, once again, pause. Try the two on your own. Then unpause. And then see if you get the answer correct. Please call me over if your answer is incorrect. So for number 7, 6 times 5 is 30. But signs are different, so it's negative 30. 14, it's three numbers. So I'm going to multiply the first two. 3 times negative 4. 3 times 4 is 12. One's positive, one's negative, so it's negative 12. I bring down the 6. I do 12 times 6, and I get 72. But in this case, one's negative and one's positive. Signs are different. So it's negative 72. And that concludes the first part of today's lesson. So in today's lesson, we're going to learn how to use integers with word problems. So we're still going to be focusing on multiplying and dividing integers. Question 15 says, a helicopter's altitude is changing at a rate of negative 17 feet per second. Find the change in altitude of the helicopter after 4 seconds. Once again, with word problems, I highly recommend the bullets, and then I'm also going to tie in some of the bar modeling as well. So when I read the first sentence, I'm going to make it very clear. We don't care about it's a helicopter, it's a boat, it's a submarine. That part we do not care about. So we only care about the number and the number what it represents. So what we do know is there's something that's changing at negative 17 feet per second. From there, the next one is pretty much the question itself. It's asking about 4 seconds. So they want to know what the change of altitude would be after 4 seconds. So change after 4 seconds. And that's all we really need to know. So now I'm going to tie in the bar model. I'm not sure if you guys know this or not, but whenever they say per something, so I'm looking right over here. So per second, per student, per car, whenever they're saying per and then they give you a label, they're referring to that label as the number 1. So in this problem, if I'm talking about per second, I'm really talking about 1 second. So you can put like an invisible 1 there to help you visually if you need to do that. So it's really negative 17 feet per 1 second. So I'm going to draw a rectangle that's going to represent the 1 second. I'm going to put negative 17 inside. Once again, this rectangle represents 1 second. Now the question is asking me for 4 seconds. So that means I should have 4 rectangles. Right? So this is 1 second, 2 seconds, 3 seconds, and 4 seconds. So in each of these rectangles, I'm going to put negative 17. So now there's two ways you can solve this. You can obviously do negative 17 plus negative 17 plus negative 17 plus negative 17 to get your answer. Or in elementary school, you learned a faster way to add a number that repeats itself, and that's using multiplication. So what I'm going to do here instead is I'm going to take negative 17 and I'm going to multiply it by 4. Once again, I'm going to multiply without worrying about the sign first. So 17 times 4, 4 times 7 is 28. 4 times 1 is 4, plus 2 is 6. Now, because one was negative and the other one was positive, and therefore signs are different, I know my answer is negative. So my final answer is there's a change of negative 68 feet. In a regional golf championship, Stephen plays 4 rounds. The score for a round is recorded as positive, over par, or negative, under par. If Stephen scores 6 points under par for all 4 rounds, what is his total score for his game? So here they're giving us a lot of information. Usually with the bullets, I do tell you to just write down the number and what it represents. But actually in this scenario, we should probably also write down a few other things besides the numbers, and you'll see what I mean. So my first bullet here. So the first thing I'm actually going to be writing down is Stephen plays 4 rounds. Or truthfully, I don't even care about Stephen, so this right plays 4 rounds. It could be Cooper or Evan. I mean, the name obviously doesn't matter. So it plays 4 rounds. So from there, this is where I was talking about before. No numbers, but we should write it down. It's telling you here that if the number is positive, it's over par. So I'm going to write over par means positive. And then over here, it's saying under par means negative. Now I can go ahead and continue just looking at the number and writing what it represents. So then, of course, the last sentence, which is really the last bullet, is asking if Stephen scores 6 points under par. So he scores 6 points under par for all 4 rounds. What is his total score for the game? Under par means negative. So in my last bullet, what they're trying to tell you without saying it is that 6 is really negative 6. Now we'll do the same thing as before with the bar model. There's 4 rounds. So let one rectangle represent 1 round. You know he scored negative 6. But of course there's 4 rounds, so I should have 4 rectangles. And in each side, each of the rectangles should be negative 6. From there, there's 2 ways of solving this. Once again, when they say total, you can add negative 6, negative 6, negative 6, and negative 6. Or, because you're adding the same number, we can then multiply. And what can we multiply? We'll multiply negative 6 by 4. So we first do 6 times 4, which is 24. And then one is a negative, the other one is a positive. When signs are different, it's a negative. So my final answer is he scores negative 24 points. Alright, so for this word problem, I recommend pausing, try solving it on your own, and then watching the rest of the video and see if you get the answer correct. The problem states, the price of a stock falls $2 each day for 9 days. Find the total change in price of the stock during this time. So we know that the stock falls $2 each day. And this continued for 9 days. And then here they just want to know the total. Find the total change in the price of the stock during this time. So short, just the total. So let's go ahead and look at the first bullet. It falls $2 each day. So just like per, each also represents 1. So when I say $2 each day, I'm talking about just 1 day. My rectangle will represent 1 day. The number I put inside that rectangle, well, it falls $2. So a lot of you are going to put 2 there, but think about it. Falls, right, down, so it's really negative 2. From there, how many days do we want to put, or aka how many rectangles do we want to put? Well, there's 9 days, so we want 9 rectangles. So I'm going to draw 8 more. 1, 2, 3, 4, 5, 6, 7, 8. So now I have a total of 9 rectangles, each one representing 1 day. Inside the rectangles, I put -2. And then from there, of course, there's two ways of solving this. I can do -2 plus -2 9 times, which I'm not going to go into, or I can do it the faster way. Once again, when you're adding the same number, you can multiply. So I'm going to multiply 9, because there's 9 days, by -2. When I multiply, once again, I just multiply the numbers. 2 times 9, 18. One's positive, one's negative. Because signs are different, my answer is negative. So my final answer is -$18. Part B, divide integers. Big idea, page 91. Division is the inverse of multiplication. So what they're trying to say is if 2 times 3 is 6, then 6 divided by 3 should be 2. So we're going to use that concept to help you with the signs as well. So we'll look over here first. We know that 3 times 5 is 15. So then obviously 15 divided by 5, right? 3 times 5 is 15. So then if I go backwards, 15 divided by 5 should be 3. So now we're going to do this one. 3 times -5, signs are different, so I know it's -15. So now I'm going to go backwards. If I go backwards, I'm looking at -15 divided by -5 to get +3. Let's see if that makes sense. -15 divided by -5 is +3. The reason why is because they're both negative, and when you're multiplying or dividing and signs are the same, the answer is always positive. Now let's look over here. -3 times 5, signs are different, so it's -15. Therefore, -15 divided by 5 should be -3. Looking over here, the -3 times -5 is +15. That's because, once again, signs are the same. They're both negative, so the answer ends up being positive. So then over here, 15 divided by -5 is -3. Once again, division is the inverse, the opposite of multiplication. So I recommend pausing and trying these two on your own, and then unpause and see if you got the answer correct. -25 divided by -5. 25 divided by 5 is 5. And because signs are the same, my answer is positive. So it's +5. Example 5. We have a negative divided by a negative. First, let's do 35 divided by 5. And that's 7. Because signs are the same, my answer is +7. Negative and positive. 81 divided by 9 is 9. Because signs are different, my answer is -9. Once again, remember, same, positive, different, negative. Only when you multiply and divide. Do not use these rules when you add or subtract integers. So for number 6, positive and negative. First, I do 45 divided by 3. Some of us can do this in our heads. This one might be a little bit more difficult if you can't. If you can't, don't forget you always can crisscross. 3 and 45. 3 goes into 4 once. Bring down the 5. 3 goes into 15 5 times. So the answer is 15. However, signs are different, so it's -15. 16 divided by 4 is 4, but because signs are different, it's -4. Here we do 12 divided by 4, which is 3, but once again, because signs are different, -3. Make sure you're asking yourself about the sign as well as the numerical answer. Here, if you haven't done so yet, pause, try the 2 on your own, unpause, and then check to see if your answer is correct. -36 divided by -4. I first do 36 divided by 4, which is 9, and then because signs are the same, my answer is +9. -20 divided by -5. I first do 20 divided by 5, which is 4. Because signs are the same, my answer is +4. So now we're going to use division of integers in word problems. So this word problem states, a submarine descends 720 feet in 6 minutes. Find the submarine's change in height per minute. So let's do the bullets first. Once again, we don't care if it's a submarine or a helicopter, but what we do care about is that it's descending 720 feet in 6 minutes. Then the question is saying, find the submarine's change in height per minute. So change in height per hint, minute. Before I solve anything, once again, per, right, a key word when you're solving word problems. Whenever they give you the word per, and there's a label afterwards, right, per student, or per car, or per block, it's always referring to that label as 1. So in this case, this is saying per 1 minute. So let's first do a visual, bar model. And all 6 rectangles equal 720 feet. If I want to figure out just one rectangle, what would I do? What would I do with 720 feet so I can separate them into 6 equal rectangles so I know how much one rectangle will be? If you said it, great. If you didn't, you should have said dividing 720 by 6 will get our answer. Now, because it's descending though, I'm going to make one thing clear. Because it is descending, it is actually negative 720. So we'll worry about the sign later. Let's go ahead and just divide 6 into 720 first. 6 goes into 7 once. Bring down the 2. 6 goes into 12 twice. Now this is a whole 0, so I need to bring it down. And even though it sounds silly, you need to ask yourself, how many times can 6 go into 0? 0 times. So now we know what the number answer is, and that's 120. But let's not forget, we're dividing a positive by a negative. And when signs are different, the answer is negative. So my final answer is that the change of height is negative 120 feet. Pause this one, try on your own first, and then check your answer. So number 10 says, find the change in height per minute of a hiker who descends 320 feet in 40 minutes. So the first bullet should be change in height per, hint, minute. Second bullet, descends, or descended, 320 feet in 40 minutes. This time, before I go into the bar model, let's get the sign first. Descend really means right down, decreasing, descend. So that's actually telling you that it's negative 320 feet. And they're doing that in 40 minutes. Now, because the numbers are so big now, I am going to show you at least something that can help you understand what operation you should do. So the first bullet, change in height per, we talked about this, per 1 minute. So they want to know in just 1 minute, what is the change? You know, in 40 minutes, it's able to go down 320 feet. So right now, try to imagine yourself drawing out 40 rectangles, and all 40 rectangles equal negative 320. How can you split negative 320 into 40 separate rectangles so that you can figure out how much one rectangle will be? Your answer should have been division. So we're going to divide 40 into negative 320. From here, there's some shortcuts I can show you, and both numbers end with a 0. I'm not sure if you guys know this or not, but you can actually cross them out and do 4 into negative 32. It only works when both numbers end in 0 and you're dividing. Not if they both end in 2s, not if they both end in 5s, only if they both end in 0s and you're dividing. You can cross out the 0s. So now I'm going to divide 4 into negative 32. Once again, let's divide first. 4 into 3, you can't do. 4 into 32, 8 times. 8 times 4, 32, and I get a remainder of 0. Now I know my answer is 8, but let's also make sure we get the correct sign. This is positive, and this is negative. Because signs are different, my answer is actually negative 8. So my final answer is negative 8 feet.